everyone, I am A.Nirisha, Assistant Professor in the Department of CSIT, working in MLR Institutions of Technology. Today we are going to discuss about dynamic memory allocations in C programming language. So coming to the overview, so we are going to learn about the memory allocation and also the types of memory allocations and also the malloc and calloc functions. So coming to the memory allocations. So what do you mean by a memory allocation? So whenever we declare a variable, a memory gets allocated to that particular variable to store its value. So for example, see here we have given here it as int e. So which means we are declaring a variable. The name of the variable is e and the data type that we are giving is integer. So with the integer we have the size is 4 bytes. So which means 4 bytes of memory will get allocated to store that particular integer value, whatever you are reading. So whenever we declare, the memory gets allocated for this e. So this e and some 4 bytes of memory will get allocated and the value will be stored in this particular allocation memory. Consider it as 10 or 20 or whatever the integer value that we are using. So there's 4 bytes. It is starting from, consider from 100, 101, 102, 103. So these are nothing but the 4 bytes of memory will get allocated to store that particular value. And then next, one more declaration we have, that is int is a of 10. That is, it is an array. We are declaring an array of 10 elements. And the name of the array is a, the data type is int. That means here for 10 elements the memory is getting allocated and each of element will have 4 bytes of memory capacity. So which means, so here we have 10 elements and the size of the int is 4. So 4 into 10 will be 40 bytes of memory will get allocated to this particular array when we have declared inside the main function. So here there are 3 types of memory allocations. One is static memory allocation, next is automatic memory allocation, and the third one is the dynamic memory allocation. So coming to the static memory allocation, when we declare the variables, static or global variables, static memory allocation is done for that particular variables. So when we are declaring the static variables or like global variables, we are declaring the global variables in the global declaration section. If you are using that particular variable, if you are declaring that particular variable, so that we can use that variable in all the blocks, like in the main function we can use, and also in the any number of user defined functions also we can use that particular variable. And next is the automatic allocation. So when we declare an automatic variable such as a function arguments or a local variables, then the automatic memory allocation is done. So inside the main function we are declaring a variables and inside the user defined functions are also we are declaring the variables. So those variables memory allocation will come under the automatic allocations. So coming to like for example the local variables whatever we are declaring, so that local variables will come under the automatic allocation and the static variables declaration that will come under the static allocation. And next one is the dynamic memory allocations. So dynamic memory allocation means allocating memory at the runtime or at the time of the execution. So only for particular number of elements we are allocating those particular memory. Say for example, so if you are declaring int a of 100. So what happens if you are declaring this array of 100 elements? So for 100 elements the memory will get allocated. So but are we using the 100 elements? Obviously no. So we are using only 10% or 20%, that is 10 elements or 20 elements of this particular array we are using. So what about the remaining rest of the memory allocations? Those memory allocations are getting wasted. So to avoid those such problems, only for fixed number of elements we are using this memory allocation functions. The first memory allocation is malloc, next is calloc, next is realloc, and for deallocation we are using the free function. So to allocate the memory for specified number of elements, we are using this dynamic memory allocations. So thus to allocate that particular memory, we are using some functions. So those functions are by using some functions. These functions are nothing but malloc, calloc and realloc. So these 3 are used for allocating the memory. And the free is used for deallocation of the memory. So whatever the memory got allocated, so that particular memory will get freed by using this free function. So the first function is malloc. Malloc is used for allocating the memory at the runtime. So here a block of memory is allocated. A large block of memory is getting allocated. And next the syntax is malloc function. And to this function, we are passing one argument, that is n into size of the data type. And here n is nothing but the number of elements. For how many number of elements you want the memory to get allocated. And this malloc function will return a void pointer. So the address will be returned to a void pointer. So here we are allocating the addresses. So we need to remind the point, that is by using dynamic memory allocations, we are allocating the memory at the runtime only for specified number of values. And here, for example, we have taken that int a. So this is nothing but allocating the memory. That is the reason why we are taking the pointer variables. So for this a, what we are assigning this malloc function and n into size of the data type. And next, this malloc will allocate the address for the void pointers. So that void pointer we are converting into the integer pointer by using this typecast operator. And here next example, we are declaring one more pointer variable, that is of character type. And then next to this a is nothing but a pointer variable. That pointer variable is of what type? It is of character type. So this thing where by using malloc function, we are allocating this size for n elements, and thus malloc the function will return in the void pointer. So for that reason, we are converting this address into the character pointer by using the typecast operator. So here see, the return type is a void. So whatever the memory got allocated, that allocated memory will be of a void pointers. So that for that reason, we are typecasting that void pointer to this particular data type values. And the next, the default value is stored is the garbage value. N blocks of memory will get allocated. So whatever the n we have, so that huge block of memory will get allocated by using the malloc function. And this is one example program to read and print 1D array using malloc function. So this malloc alloc are defined in stdlib.h header file. So if you are using the malloc function, we need to use stdlib.h header files. So this is the next is a main function, and we are declaring a pointer variable, and also we are declaring some n value and I. N is nothing but the how many number of elements you want to allocate the memory, and I we are using in the for loop. Next, by using the printf statement, we are asking to enter the number of elements, and by using the scanf statement, we are reading that particular n value. And see here, we are calling this malloc function, and to this malloc, we are passing one single argument, that is n into the size of the data type. So n is the number of elements. So what about the size of the data type? So size of the int. So we don't know what type of data we are using. So we need to specify that by using the size of the data type, we will get the number of bytes that is allocated for this particular data type, that whatever we have written in this brackets. So size of int will be 4. So and n will be, consider my n elements in the test cases I have given as 4. So n is 4 and the size of the int is 4. So 4 into 4, 16. So 16 bytes of memory will get allocated by using this malloc function. And this address we are converting it into the integer pointer by using its typecast operator. And then next we are reading all those elements. So here we have given the n as 4. So you can also give 10, 20, whatever the specified number of elements you want to allocate the memory. So here for that, to read all those values, we are using a for loop to read all that particular values. So here we are using a for loop and starting from I is equals to 0 and till I less than n. We are reading from 0 to n. And then next, by using scanf statement, we are placing that particular element in a plus I. So consider for an example, we are telling here some 16 bytes of memory got allocated. So consider this is the particular block that 16 bytes of memory got allocated for that by using this malloc function to store the 4 values. So consider the starting address starts from 100 to 103. 100, 101, 100 to 103. 4 bytes of memory will get allocated to store one single value. And then the next memory allocation 103 to 107. So next 4 bytes we got allocated to store the next value. And the next 104. and 108 to 111, and the next 112 to 116. So these are nothing but, sorry, it's 15. So this 4 bytes are used to store the first value, this 4 bytes are used to store the second value, these 4 bytes are used to store the third value, and these 4 bytes are used to store the fourth value. And here this malloc, this function, we are assigning that particular first byte address to A. So here A will have the first byte address. The first byte address that we have is 100. So here we are reading the first value. The first value is 1. We have given the 4 elements as 1, 2, 3, 4, 5. The first value is 1. So that one where we are storing it is, we are storing in the A plus I. So here A value is 100. 100 plus I value is 0. Initially we are taking I is equals to 0. So that is equals to 100. In 100th location we are storing that first value. So 1 will be stored here. And the next I value will get incremented. I will be equals to 1. So the next element we are reading by using this scanf statement, and we are storing in the A plus I. A value is 100 and I value here it is 1. So if you are adding an integer to this address, so what we need to do, we need to multiply with the size of the data type. So into the size of the data type here we are using is int. So size of the int is 4. So 100 plus 4 will be is equals to 104. So next element will be stored in this 104 address location, that is 2. And the next I value will get incremented. I will be equals to 2. So now next value, that is 3. The 3 we are reading and where we are storing in A plus I. So here A value is 100 and I value is 2. So if you are adding some constant to the address, we need to multiply it with the size of the data type. So the size of the data type is 4. So 100 into 8, that will be is equals to 108. So the next value we are reading by using scanf statement, and we are storing in 108 address location. In the same way, I value will get incremented. I is equals to 3 and 100 plus 3 into 4, that is equals to 112. So the next value will be read and stored in the 112 address locations. So total 16 bytes, 16 big block of 16 bytes of memory got allocated by using this malloc functions. And the next same, whatever the values we have read, and by using printf statement, we are printing those values. So here we have read 1, 2, 3, 4, and the same 1, 2, 3, 4 values will get printed by using this A plus I. So in front of that A plus I, we are placing a star, which means if we have a star in front of this address, it is nothing but a dereferencing operator. The star, if you have an star in front of the address, we will find the value that is present in that particular address location. We'll get the value. So in 100, what the value is present, that is 1. So 1 value will get displayed. And if you have star in front of this 104, we have 2 value will get displayed. So this was done by using these 2 for loops. The reading was done by using these statements, and printing was done by using these statements. Printf statement inside the for loop. So whatever the array problems or whatever the normal problems that we have, we can solve by using these malloc functions. And also some other array problems or 2D array problems, if you don't have some specified size, so at that time we can use this malloc and calloc. So next is the calloc. So calloc is nothing but a continuous memory allocation function. Mainly it is used with arrays. And here the syntax is a calloc and n comma size of the data type. In malloc, we are passing only one parameters, but in calloc we are passing 2 parameters, that is n into size of the data type. And the address will return in the void type. So for void pointer, the address will get returned, and that void pointer we need to convert it into that whatever the data type we are using. So next here, for suppose we are taking an example, int a, pointer variable we are declaring, and to this a we are assigning calloc 10 into 10 comma size of the int. That means 10 number of blocks will get created. In malloc, only one single large block will get created, but coming to the calloc, some different multiple blocks will get created. So for suppose we have 10 elements. So for 10, 4 bytes of memory will get allocated, and for next 10, for first element 4 bytes of memory, and for next element 4 bytes of memory, and for next element 4 bytes, and so on till 10 elements. So 10 elements, the memory will get allocated, each block of 4 bytes. The return type is void, and the default value that we are using is null, which means zeros. So before not allocating any values or before not storing any values in that particular addresses, the 0 value will be displayed. And the next we are read and print the array using the alloc function. So header files and malloc and calloc are defined in stdlib.h header file. So that is the reason why we are using that. And the next is a main function, and next we have declared a pointer variable and n and I. N is nothing but the size, and I is we are using the for loops. And the next we are asking to enter the number of elements, and next by using scanf statement we are reading that n value. And then next by using this calloc function we are allocating for n number of elements, we are allocating this size of the int. For n number of elements, each block of size of int, the memory will get allocated by using this calloc function, and this calloc function it will return in the void pointer. So that void pointer we are converting into an integer pointer by using this typecast operator. That first byte we are assigning to the pointer variables. And same here, by using this for loop and scanf inside the for loop, we are reading the array elements, and by using the printf inside the for loop, we are printing the array elements. See, for suppose, so consider my n as 3. So here I have taken the element as a n value as a 3. So consider it is starting from 100, 101, 102, 103. 4 bytes of memory will get allocated to store first value, and 104, 105, 106, 107. Next to 4, 108, 109, 110, and 111. So the values I am taking here it as 10, 20, 30. So 10, 20, 30 will be stored in that particular allocated memory. And the next, by using these two statements, we are printing that the values that are present in that particular memory by using the for loop. Thank you.